All right, I'm going to talk about the redundant or backup coverage for species. So we can ask ourselves a few interesting questions here. The first one is, what if a species can be represented in more than one parcel? That is not uncommon. We can also talk about the importance of species, right? And so this could actually be formulated with a new parameter a sub I. Now, you can directly see here the analogy with the MCLP where each demand node was weighted by its population, if you remember some exercise we have done. And what about if we were talking about regular versus threatened species? Now think about this for a second. You live in an area that's quite biodiverse, but there are species which are threatened. I think you would like probably those threatened species to be represented more than one time. Why? Because if the parcel was to disappear, maybe a fire, maybe something else, that species may actually disappear. So you want to make sure that there is some sort of a backup, right? And so it wouldn't be uncommon to have a backup that is targeted for these species that are threatened and a regular coverage for those species which are not threatened. So we are going to come up here with a bi-objective here. Now, in most of the examples that I have taken on the species covering, I've always assumed that a sub I is equal to 1. So all species are the same, but very easy to change that. And we would have two objective functions. The first one would be to maximize, of course, the representation of each species, while the second one would be to maximize the backup or redundant coverage. So each species is represented more than once. Subject to a few constraints, of course, we are going to say here that there should be a certain number of parcels such that either backup coverage or regular coverage is guaranteed. So, for instance, if U sub I is if a species is in more than one parcel, is equal to 1, okay? This is also going to be equal to 1 because if it's backup coverage, it must be covered. So this should be equal to 2, right? And then that means here we should have at least 2 parcels that are going to cover. Now, if U sub I is equal to 0, and this is 0, well, we don't need any parcels to harbor species I. If the species was not backup, but the regular coverage, then there should be at least 1 parcel to cover or to represent that one species. Now here we're basically saying that if a parcel, if a species is backup coverage, they should at least be, it should at least be represented once, okay? And here we have a limit on the number of parcels that we can have, and we have already discussed other form for this constraint, okay? So this is very important. I'm going to show an illustration that we will then afterwards solve within Cplex, so you can understand the formulation, the mechanism, and in that particular formulations, once we get into Cplex, I'm going to play with the weights, so you can see that I can put more emphasis into the second part of the objective function or into the first part, okay? So hang on and let's go over the illustration. Okay, as promised, an illustration of the backup coverage model. Here we have 5 parcels. This is the same setup for the maximum covering species problem. We have here the objective function, so we have weights here that either reflects the regular coverage or the backup coverage, W1 minus W. Here I have assumed that each species carries the same weight, so that's why the coefficient is a 1 in front of them. And then you have all of these different constraints that are worked out for each species, right? So for instance, if we take A appears in 1, A appears in 3, and in 5. So you have 1, 2, and 5, okay? And so on and so forth. So depending on where you want to put more emphasis, then some specific parcels would be selected. Now this is a small problem, of course, so we will have to try to scale it up as I will give a couple of homeworks related to this. And then of course we have this constraint that stipulates that there is a finite number of parcels that can be purchased or maintained given a certain budget. Again, I'm going to use Cplex now to try to solve this problem and then see which solution is going to be selected. Okay, I'm going to show now a small example here. In Notepad I have prepared the LP file So the decision variable y sub a would be equal to 1 if species A is in the system and 0 otherwise, and likewise for the other species. U sub A would be equal to 1 if species A is represented at least 2 times. The problem with this model, it doesn't really keep track of whether a species is represented 3 times, 4 times, 5 times. So that's something, you know, as you think for, let's say, final project for this class, you could possibly think about a model that would track how many times a species is represented, not just whether there is a backup, but maybe even more. You have the set of constraints that similar, like I explained on the blackboard here, and then binary integers for the x's to sort of the parcels, whether we open or not, for the u's, which are the backups, and the y's, which is basically whether species is present or not. So if I were to go here, so this I call this one this sort of regular, because you can see the weighting scheme is the same for whether regular or backup. And so here I'm going to do read. I'm going to take the backup species right here and carry this there, put LP, and then optimize it. Okay, with an objective function of 3.5, if I want to display the solutions, variables all, and this is for 2 parcels, by the way. Okay, I will tell me that x1 and x3 are selected. Okay, so let's keep that in mind, x1 and x3. We can see here 1 and 3 being the parcels that are selected. Let's now change the weight a little bit and see if the model is actually different. All right, so now the other example is where I really changed the weight a lot. And in this particular example, right, as you can see, I have put a very, very high weight that is basically almost 1, 0.99999, y sub a, and so on and so forth. So let's just see here. And then for the backup, I gave almost no weight at all. It's still there in the objective, right, but almost no weight. And so what would you see essentially is that this is going to be very close to the maximum covering species problem. Okay, so let's go and save this, and let's well, it's not this one, right? So it's the other one. So it's just the weighted here, and LP, and optimize this one. We'll see the objective function is different, very close to 6. Remember 6 when we had this one before. And then display the solution variables. And now we see that x2 and x3 are selected, unlike the one before. So giving more weights to a particular objective may actually change the solution. No, because our problem is not very, how to say, it's not very large, because every species weight the same way, it is pretty clear that we're not going to see a whole lot of difference. Now, if the problem was larger, if there were more species, less species in each parcel, then you would really start to see some differences. And this will be part of one of the homework that we hope to do in this class.